our world and beyond. Space, in partnership with the European Space Agency.
It is a complex machine, weaving together thousands of strands of silk. It was the brainchild of the man who developed the punch card. This is the loom, invented in the 18th century by Joseph Jacquard of Lyon. There is the same precision and complexity on this 21st century machine. Now there is no longer silk, but carbon fibre. The old loom weaves together the various strands to make the perfect patterns in silk. These miles of carbon fibre on the strange modern loom will be woven into a huge black cocoon. This is the main body of a rocket, a special one, as it's the youngest of the European space industry and specifically designed for launching light loads. This is Vega.
In the past years, Europe had the need to launch payloads of the class of Vega, and this was done normally with other launchers, mainly Russian launchers derived from the old ballistic arsenal of Russia. And now with this we have an autonomous means for Europe to have the access to space also for this class of payloads.
Antonio Fabrizi is the guiding power behind this project. It is his baby, and he's invested a lot of hard work in making it a reality through the cooperation of the European Space Agency. Initially, though, the project was just Italian.
I've been working on Vega since the very beginning. The initial idea was in Italy was coming from the original program of San Marco. Italy was launching the American Scout launch vehicle from the platform in the Indian Ocean in Kenya, and this program at a certain point in time was considered important for these small missions, and this was at the end of the 80s.
The University of Rome and the Italian Space Research Centre joined together in the 60s to work on the San Marco satellite project. San Marco 1 was launched in 1964 and was the first European satellite to go into orbit, following those of the Soviet Union and the United States.
But then the American Scout was going to be phased out, and the production was quitted by the Americans, and so we transformed this initial idea into something more European, and we started thinking on a pure European launchers.
A small-scale replica of the new rocket greets visitors at the entrance of Esran, the Centre for Earth Observation of the European Space Agency in Frascati near Rome. This is home for the Vega program team. One of the priorities is to standardize the maximum production of the various components and systems.
Vega is a 4 stages launchers. The first 3 stages are based on solid rocket boosters, and to have the same technologies for the 3 first stages based on solid propellant and the composite case, so a lighter case based on carbon fiber composite structure. To have also the same technology for the nozzles and for the actuation of the booster.
The first 3 stages are solid propellant. The first, P80, will burn 80 tons of fuel in 106 seconds. The second, called the Zafiro 23, as seen here when it was tested in Sardinia, will consume 23 tons in 71 seconds. The third, the Zafiro 9, as it is 9 tons, will operate for 110 seconds.
Solid rocket motors are very easy to manufacture. They do not have the same high performance as cryogenic engines, but they are more easier to operate and to manufacture, and they have a lower cost. So again, this rocket families, the booster families, comes from Variant 4 development, goes through Variant 5 developments, and comes to Vega.
The town of Colleferro, some 60 kilometers south of Rome, is the main construction base for the project. A set of buildings is dedicated to Ariane 5 and specifically the enormous EAP boosters. These long tubes of 31 meters with a diameter of 3 meters are treated with thermal insulation so that they can withstand the tremendous heat generated by the burning propellant.
Avio ha un'esperienza pluridecennale nel campo della propulsione.
Avio has a multi-decade experience working with solid propellant propulsion. The Ariane 5 program is an example. We've been working for 14 years now on that program, and our production rhythm is around 6 or 7 launches a year.
6-7 lanci per anno.
These boosters are essential for the takeoff of Ariane 5. They provide about 90% of the energy required to lift the 780 tons of the rocket.
Da oltre 15 anni di lavoro consolidato.
Working for 14 years on the Ariane 5 program, we've acquired a good knowledge about composite materials and their use on a large scale. This was a very important starting point for the development of the Vega program.
Ha rappresentato per noi un punto di partenza importante per iniziare la fase di sviluppo del programma Vega.
So, Vega. 3 parts of the rocket have already reached the later stages of construction, together with 3 others which will complete the test flights. To be flexible in this workspace, moving the heavy equipment, such as part of one of the launchers, for example, is done by a machine that glides on a cushion of air. Then there is the crucial step, weaving different coverings onto the body. The core is first covered with a layer of special rubber, which has a large thermal power. And then
Il ciclo di fabbricazione per filament winding è la fase più importante.
The filament winding cycle is the most important phase in the manufacturing of the 3 elements of the Vega launcher. It's made here with a sophisticated system called the delivery system, which aggregates the filaments of 30 reels and creates a 10-centimeter large strip that spins around the mandrel, following the computer program which drives the machine. This process permits the winding of the body of the motor, which then goes to an autoclave for the polymerization cycle, which will give the requested mechanical characteristics for the mission. The P80 built in this plant is the biggest monolithic motor in the world, and for that, 3,000 kilometers of this fiber are needed.
Another innovation on Vega is the movement of the nozzles of the various stages. Throughout the flight, the trajectory of every level has to be corrected on a command from the onboard computer. To date, these controls were hydraulic. Now they have become more accurate.
On all stages of Vega, we have electric actuators instead of hydraulic actuators, and this is also a new technology for Europe, which is providing interesting perspective of application in future launchers programs.
Towards the setting sun in the west and Europe's spaceport in French Guiana. The various elements of the launch vehicle have been transported by boat, followed by weeks of assembling the various parts, as well as a series of test launches, without actually firing the rockets, of course. The second and third stages of Vega arrived from Europe, already assembled with fuel on board. As the first stage is much bigger, it was put together on site in Kourou, and for security reasons, the propellant then loaded.
We are using the same principle as Ariane 1 and 4 with a mobile gantry which is used to integrate the launcher and then is moved away 100 meters to enable the launch. This mobile gantry is a tower of about 1,000 tons heavy and hosts all the facility which enables the integration of the different stages and the electrical check of all the stages.
The fourth and last stage differs from the others. It is powered by liquid fuel. It will carry the payload and is also home to the onboard computer, the navigation system, and the so-called safeguard that controls the destruction of the rocket in case of any anomalies during the flight. It is the brains of Vega.
The last stage, the so-called AVOM, has a liquid engine. Why a liquid engine? Because the first 3 stages are solid propellant boosters and need a very precise engine on the first stage to make the last maneuvers for the pointing and before putting in orbit the satellite. This engine is also reknitable, and this will enable to put satellite on a different orbit.
For this inaugural flight, the payload includes 7 small satellites called CubeSat class, built by various European universities to introduce students to the disciplines of space. 2 other missions of the Italian Space Agency complete the list of passengers: a microsatellite test, AlmaSat-1, and Lares, a rather strange sphere.
So this sphere, very high, dense sphere and very heavy sphere, has laser reflectors. The idea is to measure the orbit with precision of this sphere by sending laser messages from the Earth, and by the speed and the time of this laser coming back to Earth, we can measure exactly this orbit.
And this is an animation of the launch. The first and the second stage boosters fire to take the rocket up to an altitude of about 185 kilometers. The fairing opens to reveal the payload compartment, which it has protected. Then it will be the turn of Avim to take the passengers, the 9 payloads, to the altitude of orbit at around 1,450 kilometers. Avim will be reignited on 3 occasions.
There is always an emotion when we hear the music of the propulsion roaring in the sky. I mean, that's always something impressive. But in this case, it will be, yes, quite challenging for my heart.
Vega has several satellites on its order book, the so-called small or medium loads. With Vega, which joins Ariane 5 and Soyuz, European rockets can now, from Kourou, launch into space all types of satellites.